We know that there's an interplay between area and perimeter. We've already looked at a time in which the area was fixed. Now let's take a look at an example in which the perimeter is fixed. The example is this. Suppose you have 50 yards of wood to build an ice skating rink. Maybe something like that in your backyard during the winter. And all you have is 50 yards of wood and that's it. Well, out of those 50 yards of wood, you could create a lot of different rectangular structures, some of which I've put up on the board. I've gone from having a length of 1, a width of 24, something very, very skinny and long, to something that's a little bit more like a square, 12 by 13. I've only included a couple of the pictures, and I've only included a few of the lengths and widths, just to prove the point that we're trying to see here. Even though the perimeter here is fixed, this is a fixed number, it's 50, and it hasn't changed from 50, and it won't change from 50. That's all the wood you have. Even though that's true, the areas are obviously not. We go from this long, skinny rectangle only having an area of 24 to growing until we get to this bottom one, 156 square yards of ice skating space. Now, if it's you or if it's me trying to build this ice skating rink, my guess is you're going to want to get the most ice skating space as possible. And what happens is you get that when your rectangles become more and more like a square. In fact, we would say that a square maximizes the amount of area that you can get for a certain perimeter. And that's what this example can show us, the importance of a square when trying to maximize area.